Hello everyone, this video is about independent and dependent events. We're going to be looking at what the difference between those would be and then also how to calculate the probability of both of them. I am trying out some new recording today to try to make it a little bit easier to write in how to do the math, so hopefully it's not too much of an issue as we go through. Okay, so we're going to start with just what the difference between those two things would be. So you've heard the words independent and dependent before. Independent is when you're not relying on anything else, or maybe you're not affected by anything else. You're kind of just on your own. So for probability, an independent event means that one thing does not affect the other. So if I were to flip a coin 5 times, what I get on each flip is not impacted by what came before. So that would also apply to rolling a number cube or spinning a spinner. Doesn't matter what you got on the last roll or the last spin, you still have the same chance of getting each outcome on the next one. So we've done a little bit of this already. When you're finding the probability of independent events, you're just going to be multiplying both of those together. So what's the probability of the first thing multiplied by the probability of the next thing? Okay, to kind of contrast with that, dependent events, dependent means that you are relying on something else or you are affected by something else. So for probability, the first thing will affect the probability of the next thing happening. So that might be something like if you have a deck of cards and you were to have your first friend pull out a card and your second friend pull out a card, the second friend, they have one fewer cards in the deck, and so their chances of getting each card are going to be a little bit different than what happened for the first person. So pretty much anytime you're taking like more than one thing out at a time, whether it's a bag of marbles or a deck of cards or something like that, whatever happens the first time, if it affects the second thing, then that would be dependent. And so when we find the probability, it's going to be kind of similar, except for this part right here, you need to adjust the second probability to reflect what happened the first time. Okay, so we'll go through that in a little bit and you'll see some examples. So let's just start by trying to identify some of these. It says, are the events independent or dependent? So if I were to randomly choose one student to participate and then randomly choose another student, do you think that would be independent or dependent? All right, so because I am choosing 2 different students, I can't choose the first student again. And so that's going to be an example of dependent events. Okay, for our next example, if I were to flip heads on one coin and tails on another, so I'm flipping 2 coins at the same time, would that be independent or dependent? So because the second coin is not going to be influenced by the first coin, that would be an example of independent events. All right, so this example here, we're going to spin a spinner and then we're going to flip a coin. So that would be an example of independent events because the spinner doesn't affect the coin and what it's going to land on. A multiple of 2, that would be things like 2, 4, 6, 8. So we'll just circle 2 and 4. So the probability that we get a multiple of 2 would be 2 out of 5. And then the probability that it would land on heads when we flip the coin, that would be 1 out of 2. And so we'll multiply those two things together. And 2 times 1 is 2. 5 times 2 is 10. And then if we simplify that fraction, we'd get 1/5. So the probability that we get a multiple of 2 and heads would be 1 out of 5 chances. For this next example, we're flipping 2 quarters. We have a tree diagram set up for us, so that'll help out a little bit when we find our probability. We want to know what the probability of flipping 2 heads would be. So the probability that we get heads on the first coin would be 1 out of 2. And then the probability that we get heads on the second coin is also 1 out of 2 because the first thing doesn't affect the second one. So when we multiply that, we would get 1 out of 4. And then because we have this tree diagram, there are 4 total outcomes, and one of those 4 represents getting 2 heads. So that's another way to see that our probability of 2 heads would be 1/4. For the next set of problems, we are going to have a bag with some marbles in it. We're going to pull a marble out, leave it out, and then pull out a second one. By the way, this is going to represent the same thing as if we were to just pull 2 marbles out at the exact same time. All right, so with what we have right here, the probability of getting a blue would be 3 out of 6, or you could write it as 1/2. I'm just going to leave it as 3/6 for now. Okay, so we're going to assume that we get a blue on our first try. So I'm going to take that out. It's not in the bag anymore. And now I want to know the probability of getting a yellow. So there are only 5 marbles left. So our probability would be out of 5, and one of those is yellow. So we'll go ahead and multiply, and we'll do 3 times 1 is 3. 6 times 5 is 30, and that would simplify down to 1/10. For our next example, this is what we have in the bag. Same situation. We're going to pull a marble out, leave it out, and then pull out a second marble. So we want, what's the probability we get blue and then red? So the probability that we get blue is going to be 1 out of 6. And then we're going to pretend like we got blue, we took it out of the bag, and now the probability of getting red would be 2 out of 5. So we'll multiply those numbers together. 1 times 2 would be 2. 6 times 5 would be 30. So our probability that we get blue and then red would be 1/15. So for this one, we are going to have a bunch of little math ninjas all in a bag. It says you're going to pull one out, leave it out, and then pull out another. So still a dependent probability that we're calculating. Okay, so it says what's the probability that you pull out a yellow and then a blue? So yellow would be a probability of 3/9, and then, or 1/3. And then we're going to pull a yellow out, keep it out, and then do a probability of getting blue. So probability would now be 3 out of 8 because there's one less in there. Okay, we'll go ahead and multiply those. 3 times 3 is 9. 9 times 8 is 72. And then that could simplify down to 1/8. For this one, I'd like you to try it first, and then we'll check and see how your answer compares. Okay, so we're going to do the probability of getting a red. That would be 1 out of 9. Take the red out, and then the probability of getting a green would be 2 out of 8. And then when we multiply those two things together, we would get 2 out of 72, which is the same as 1/36. Okay, for this last set of examples, we're going to be looking at tiles. So it says you randomly choose one of the tiles. Without replacing it, you choose a second tile. So we're not going to put it back. We want the probability of each thing. So we're going to do 4 different problems altogether here. So the probability of choosing a 5 and then a 6. So there are 1, 2, 3, 4, 5, 6, 7 tiles. And so the probability of choosing a 5 would be 1 out of 7. And then because I took out the 5, now I'm going to find the probability of getting a 6, which would be 1 tile out of 6 options. So we'll multiply those and get a probability of 1 out of 42. All right, go ahead and try this next one. Probability of getting an odd number and then a 20. So we're still starting with 7 tiles. We reset each time. So the probability of getting an odd would be 1, 2, 3 out of 7. And then a 20, we took out one of those odd numbers. We don't know which one, but it doesn't really matter. We just took out an odd number. So there are 6 tiles left, and one of them is labeled as 20. So that would be 3 out of 42. And then that can simplify down if we divide both of them by 3. That would be 14. So 1/14 for that one. Okay, for our next one, we want the probability of getting a number less than 7 and then a multiple of 4. So let's see, I'm actually going to give myself a little bit of space. So I'm going to write it down here. So the first time we draw a tile, there's 7. The second time, there's only going to be 6. So a number less than 7, that would be 5 and 6. So it looks like there's 2 out of 7. We take one of those out, so that's why there's 6 tiles left. And then a multiple of 4, that would be either, let's use a different color here, that would be either 8 or 20. Those are the only multiples of 4, so that would be 2 out of 6. So 2 times 2 is 4. 7 times 6 is 42. And then we'll divide both of those by 2 to get 2 out of 21. So choosing a number less than 7 and then a multiple of 4 is going to be 2 out of 21. Okay, we'll reset here for the last one, choosing 2 even numbers. All right, the probability, set it up starting the same way. 7 tiles the first time, 6 tiles the second time. So even numbers would be 8, 6, 10, and 20. So the first time that we reach into the bag here, the probability would be 4 out of 7. You take one out, doesn't even matter which one, but the important part is that there are 3 left. And so you'd have the probabilities 4/7 times 3/6 multiplied together. So for this one, I'm actually going to simplify first. This could simplify down to 1/2. And then if I simplify another time, 4/2 could simplify down to 2/1. So if I do this, I'd get 2 on top, 7 on the bottom. If that is a little bit confusing, just know that without doing that, I would have had 12/42, which will simplify down to the exact same thing. So either way, you'll end up with 2/7 as your final answer. All right, thank you for watching today.